Python numbers. We are having different type of numbers we can represent in Python. We shall be discussing on that. Number data types. So Python supports three number data types. The first one is the integer. There is the integer numbers like your 100, 2030, something like this as an example. Floating point numbers, these are the examples are given, and complex numbers are to be written in this particular format. So like your 3 plus 4j, 5 plus 10j in this way. We can use a type function to know which class a variable or a value belongs to, an instance function to check if it is belong to a certain particular class or not. So we are having two functions. One is the type, which will tell the type of the function, and another one is the instance, which will tell whether this particular variable is of that type or not. While integers can be of any length, a floating point number is accurate only up to 15 decimal places. That is, the 16 decimal place will be incorrect in that case. So that is the precision we are having for the floating point number. But in case of integers, while integers, it can be of any length. Numbers we deal with every day are decimal, that is the base 10 number system. Python can also express binary, octal and hexadecimal numbers also. As computer programmers, generally embedded programmers, need to work with the binary. The binary number system is having the base 2, or the hexadecimal, that is the base 16, and octal, that is the base 8 number systems. In Python, we can represent these numbers by appropriately placing a prefix before that number. Now, what are the prefix? So here you see we can write here as 0 small b or 0 capital B as a binary number prefix. We are having this 0 small o or 0 capital O as octal number prefix. We are having 0 small x or 0 capital X as hexadecimal number prefix. So these are the prefix we are having to represent the respective number. Number type conversion. From one type to another type, we can do the conversions accordingly. We can also use the built-in functions like your int, which will convert to the respective integer, float and the complex functions. To convert between types explicitly, these functions can even convert from strings. So it can take a string as input and convert it to integer, in this case convert to float in this case, and convert to complex number using this particular complex function. So I think let us go for one demonstration where we will be discussing how these numbers can be operated, can be handled, can be doing the typecasting in our Python coding.
Numbers in Python can have mainly three different data types. First one is the integer. So here you see the value 1 is equal to 100. So this 100 is of type integer. And then we are having the next one as float. In case of float, value 2 is equal to 100.24. So it is of the type float class. And this particular float will always have some decimal point here and fractional part will be there. And then we are having the another type that is known as a complex, and this complex type numbers will be expressed in the form of the 15 plus 6j. So it is one of the examples we have given. So we are having three different types are there. One is the int, next one is the float, and the last one is the complex class in our Python. And integer and floating point numbers are separated by the presence of or absence of the decimal point. So in case of 5, if you write only 5, it is an integer, but if you write the 5.0, it will be of the type float. Okay, so now here you see we are having this value 1 initialized with the value 100, and then we are going for the print type of value 1, and also we are checking is instance value 1 int, value 1 float and value 1 complex. If I execute this particular part, we are getting this type as class type of int, and this is instance will always return a boolean. It will check whether this value 1 is of the type int or not, and that is true here, but in case of float and complex, it is returning false. Similarly, we are doing the same type of testing here. In case of value 2, if I go on executing, we are getting the required output. So value 2 comma int, if we pass these two parameters to is instance, I'm getting the output false. But here in this case, as this value 2 is of type float, so is instance value 2 comma float will return true, and value 2 comma complex will return false here. So now let us go for this complex. So here we are having value 3 is equal to 50 plus 6j. So if we go on executing, we are getting the output like this. So in case of int, in case of float, with the isInstance method, we are getting this false, but with the complex isInstance value 3 comma complex, it is returning true here. So in this way, we have tested that how the number instance can be tested, or the number type can be tested using the method isInstance. This Python, in case of Python, also we can have other different corresponding representations of data. There is a binary which will have the base 2, hexadecimal which will be having the base 16, and octal which will be having the base 8 here. So numbers we deal with our everyday are having the base 10, that is our decimal numbers. But other than this decimal, you can work with the base 2, that is the binary number system. We are having this hexadecimal with the base 16 and octal with the base 8 here. So to represent one binary number, we can easily write 0b as a prefix to this number. You can write this b in the capital letter also. So if you go on printing this 0b 1101, that means this 1101 is not in decimal but in binary. 0x will stand for the hexadecimal and 0o will be standing for this octal here. So now let me go for the execution. You can find that if I execute this part, I'm getting 13 because 8 plus 4, that is 12 plus 1, that is 13 here. Because this particular place is having the place value to the power of 0, that is 1. This particular place is having the place value to the power of 1, that is 2. To the power of 2, that is 4, and to the power of 3, that is 8. So 8 plus 4 plus 1, 13 we are getting here. So in case of this 0xab, so a is having the value in hexadecimal as 10. So 16 to the power of 1 into 10, we are getting here 160, and b is having the value 11. So 11 into 16 to the power of 0, so you are landing with 11 only. So 160 plus 11, we are getting the value 171. In the last case, you can find that it is 2 into 8 to the power of 1, because it is represented in the terms of octal. So 2 into 8 to the power of 1 plus 3 into 8 to the power of 0. So we are getting this value 16 plus 3, and that is 19 here. So in place of writing this small b, you can also go for the capital B. This is, I'm replacing this one as capital X and replacing this one as capital O. Then also we are going to get the same output here. Now here you see, here we are having this particular value 10 in terms of integer, and 13.4 is nothing but a float data. So what will happen if you go on printing this one? So you see the result is being converted to the respective float here. So operations like addition, subtraction, which is dealing with this integer and the float, and then automatically it will be converted to the float implicitly. So here you see we are having this integer operand, here we are having this float operand. If any one of the operand is float, then the result will be implicitly converted to the float type. So now we are going to have this type conversion. So 10.5 is of the type float, and if we want to convert it to integer, we can get the output like this. So 10 is getting output, is producing the output. So now here we are having this minus 20.99, so it is a float type. So if we do the type casting to integer, we are getting this one as minus 20. So we can find this one that when we are doing the conversion to integer, it is not changing the sign of the number. So here we are having this float 10. So this 10 is of the type integer because there is no fractional part, there is no decimal point. But as I did the type conversion here, so the output has become 10.0. Now consider this example. Data 1 is equal to 0.1 plus 0.2, and we are just printing the value of data 1. So if I execute this code, we are finding that we were expecting the value should be printed as 0.3 because 0.1 plus 0.2 should be 0.3, but we are finding that we are having so many different zeros after that, and then 1.4 is coming. So this is an error is getting caused due to the hardware of our system, not due to the Python. So if we want to check whether 0 plus 1 plus 0 plus 0.1 plus 0.2 is 0.3 or not, then in that case we'll be finding that the condition is giving the output as false. To overcome this issue, we can use the decimal module that comes with Python. And while floating point numbers have the precision up to 15 decimal places, and the decimal module has user settable precision accordingly. So here you see we are having this data 1 is equal to 0.1 plus 0.2 print data 1. So we are getting this output as 0.3 and multiple number of zeros and 4. And then here also we are just doing one calculation, that is 1.20 into 2.50, and we are printing the value of data 1. We are getting this 3.0 as well. So now from decimal, import decimal as a D. So if you now do the calculation in this way, you can see we have written this particular code and we are going to print the respective result. We are getting the value as 0.3, which was expected, and for this outcome we are getting this output as 3.00. So in this way, the problem which we are facing in case of Python can be overcome using the from decimal import decimal. Here this decimal D will be in the uppercase. So here we are use one alias, that is as D here. Now we shall discuss fractions. Python provides operations involving fractional numbers through its fractions module, and this fraction module will help us to convert one floating point number to a numerator denominator form, where both the numerator and the denominator will be of the type integer. Actually, fraction has a numerator and a denominator, and both of which are integers, and this module has support for rational number arithmetic. So let us go for this example here. So you see that from fractions, import fraction as f, and this is a respective module we are executing here. So you can find that 1.5 can be expressed in terms of 3 by 2, and this 3 is nothing but one integer numerator, and 2 is nothing but another integer which has been placed as the denominator. So print f5, which will give you the 5, and print f1 comma 5 will give you the value, that is 1 by 5. So while creating fraction from float, we might get some unusual results, and this is due to the imperfect binary floating point number representation. And fortunately, fraction allows us to instantiate with a string as well, and this is preferred option when using the decimal numbers. Now we shall discuss the math module. Python offers module like math and the random to carry out different mathematics like your trigonometry, logarithms, probability, statistics, and etc. So just consider this set of code. So Python math module. So we have imported the math, and then we used multiple different functions available in the math here. So pi, cos, log, log of 10, exp, factorial, and signage. So here is the respective outputs we are getting here. So if we want to print the absolute of say minus 12.34, if we want to print this one, then in that case we need not to use the math module here. So we can use directly as abs minus 12.34. You can find that we have considered only the magnitude part and the sign part has been ignored. Now let us come to this, that is the random here. So here you see we are going for the rand range, that is 5,15. So the initial value is the start value, which is optional. If you don't provide any initial value, the value will become considered as 0. And the last one, the next one value, that is the second argument we are passing, is mandatory, that is the terminating value or the stop value, and that is exclusive. That means here the random numbers will be generated inclusive 5 to 15 exclusive. So in this way you can go on printing and we can generate multiple random numbers are there. So the first value is optional, that is there is a start value. The second value is mandatory, that is a stop value. Then you can also put another argument, comma, after putting comma there, there is a step value. So here we have printed rand range in between 5 to 15 4 times. So now we are having this 11, 8, 14 and 13. If I execute the code once again, we are getting the different set of values. If we execute the code once again, we are getting different set of values. So now we are having one list here, then random.choice day. So day is nothing but the list. Here you see it has picked up the random choice is 2. If you go for execution once again, we are getting this value as 2 here once again. So if you go for again, you can find that we are getting here mon here. So now this is a print day. Now we are going for random.shuffle day. And then if you print day, we can find that this is the respective different arrangement of this list elements, and list elements have got shuffled. And then we are having this print random element. So if you want to print the random element, then the method is random, so we can print the respective random element here. So in this way, in this particular program, we have discussed multiple different aspects of number type in our Python. So let us go for a quick revision. So type is actually returning the type of the variable. Each instance is actually checking whether this particular variable is having this type or not. So that's why this is instance is actually returning true or false. So we have tested that one on integer, we have tested that one on float, we have tested that one on complex numbers. So here we are expressing numbers in terms of binary. So the prefix will be 0b, b can be small letter or capital letter. For the hexadecimal, the prefix should be 0x, x can be lowercase or in the uppercase. And for the octal, we are having this value which will be having the prefix 0, o can be in the lowercase or uppercase. So here you can find that whenever we are doing some calculations involving integers and float, the result will get implicitly converted to the float. We're having to for this type conversion from this float to the integer, from this float to the integer, from this integer to the float, respective outputs are there. We have discussed this decimal here, how we can deal with we can have the control over the precisions. And then we are having this Python fractions. You can see that how the fractions are working, and then the math module and also the random module here. I think now you are getting this idea that how these numbers are getting handled in our Python programming. Thanks for watching this video.